Okay, now members, we are going to see power when we are dealing with the traders. So, traders, I have got some simple which you can show a trader. Orange, I think you can see. This one is acting as the head. It's going to be pulling this trader here. The method that is connecting these two, this is what we call a toe. So it's connecting these two, but of course there will be some tension. So as this one is moving, it's going to be pulling that in that order. So what they are pulling is the trader, and then this is the car. So that's going to be the idea. So this is the car, this is the trader, and then this is going to be the toe that is connecting this to this. Okay, so after that, let us see our question we have there. So the question we have here is, a cold mass 10 newtons tows a trailer of mass 40 newtons along a level road. It's along a level road. A car experiences a resistance of 100 newtons and the trailer resistance of 2000 newtons. If the engine car works at a constant rate of this and the speed of this, find acceleration produced. So from there, first of all, we know that they are giving us power. So our power is 400 kilowatts, which are going to be 400,000 watts. We first convert power to watts. Now they are giving us speed or our velocity, which is given as 72 kilometers per hour, which we are going to convert to 72 times 1,000 over 360, and now this will be 20 meters per second as a unit for velocity. So mean that now the force, the driving, remember our power is equal to F times B. So now our attractive force is going to be P over V. So our force that is going to be driving this car is going to be now 4,000 over the speed, which is 20. So this goes there. Then this is that our attractive force. This is what we call the attractive force. It's going to be 20,000 newtons. As simple as that. So if you have that, then we can come for our sketch. So we have a car. So start with our car here. This is going to be our car. This one is 100 tons. 100 tons means 10,000 kilograms. Of course, we are going to be having weight of 10,000 G. And then this one is going to be having reaction 1. Okay, so you also have a trailer. This trailer here is 40 newtons with a 4,000 kilograms. So the weight is going to be 40,000 times B. So that's the, now we have a toe. A toe is a load that connects to these two. So this is going to be our toe. It's a rod that's going to connect to these two. Of course, tension, there are going to be some tension. It's going to be the same there. Okay, now this car, this is our car, and then this is our trailer. Of course, this car, there's going to be a force that is going to be driving it. This force which we've seen is going to be 20,000 newtons. Okay, now remember it has a resistance. They're telling us that a car experiences a resistance of 100 newtons. So we are going to be having a resistance of 100 newtons and the trailer resistance of 2,000 newtons. So this one is also going to be 2,000 newtons. Opposite to the direction of acceleration. That is going to be a direction of acceleration because this which is pulling in that direction. So part A, acceleration is produced. So there are two ways you can do this. So I'm going to give you one, you choose what you take. So method one, you can get, this one is also going to be having resultant. I mean the reaction between this and the rod, as you can see there, in that order. Sorry. So from there now, in method 1, we focus on each. So we come to the trader. The trader, remember our FR, resultant force, is going to be equal to MA. And the direction of acceleration is in that order. So what is pulling it in this direction is the T. Then minus, we have opposing force, which is 2,000, equaling to the mass, which is 40,000 times the acceleration. And we call this equation 1. Then when we come to the car, our car, you see that now for it, its acceleration is still in that direction. So it's still our FR is going to be MA. So what's the result? Now what is pulling is this force, which is 20,000. Then minus. There are two things opposing. There is T and then there is this. So minus T, then minus 100, equaling to the mass, which is 10,000 into the acceleration, which is A. So from there, when we simplify, you see when we get this, we get 9,000 minus T equaling to 1,000, 10,000 A. And call this equation 2. So you can, every step we are going to solve these two simultaneous, and then that would be the idea. So you say 2 plus 1. 1 plus 2, when we add, so we have T. T minus 2,000 equaling to 1,000 A. Then we come to this, allow me to start with the negative T, then plus 19900 will be equaling to 10,000 A. If we add these two, this will go to 0. When we add it, we are adding. When I add this to this, I get 7,900 equaling to, when we add here, we have 50,000 A. And from there, our acceleration is 0.358. And this is going to be meters per second squared. So that is our acceleration. Method 2, you can consider this as one system. So it method 2, okay. Maybe first get the attention. So that is our acceleration. That was part A. Then part B, let us get our tension. So our tension from here, from 1, our T is going to be now 440,000 into 0.358, then plus 2,000. And so our tension here is going to be 16,320 newtons, and that would be the answer. Really easy. So the other alternative, the method 2, we consider them as one mass. So we consider this as one mass. This and this, consider it as one mass. We consider car and trailer as one mass. So what is it giving me now? So if I consider it as one mass, this is going to be the idea now. The idea, we can consider it as one mass and we get the acceleration. Then the tension, then we come to this. Or if you don't consider it as one mass, this would be the other way round. Once my duster. So the other way around, if you consider it as one mass, you can easily get the acceleration. Then we focus on one. So if you consider it as one mass, we shall get now the 4,000, then plus the 10,000. Now the opposition we are going to be having now 2,000 newtons and also 1,000 newtons on this to this and this. And then we are going to be having a force which is driving 20,000 newtons. So in this direction, of course. So from there we now say our resultant is equal to mass times acceleration. The resultant, we get this, which is in this direction of acceleration, which would be 2,000, 20,000, then minus 2,000, then minus 1,000, and 100 equal to 2 mass. Now the combined mass, which is 50, then times the acceleration. And you see there, when we combine the two, so we are getting 17,900 equaling to 50,000 A. And you see that our A, then you can see this listed here, 0.358 meters per second square. Then after, you could come here and then get our T from here in the way you want. Or if you want, then you can say, if you consider this as one mass, you say the forward force, these ones are going to be cancelled. Then minus this equaling to mass times acceleration. It will also work. Or should I write it anyway? Or anyway, you've got the idea. So that's it, members. And then after here you can come and get your tension. So that's it. See you.